Okay, so today we're going to go on to complex numbers. And I think that just made my screen smaller, didn't it?
Look bad.
I don't know. Okay, so complex numbers. Complex numbers involve our imaginary. So what we're going to be doing today is simplifying imaginary numbers and adding, subtracting, just basic math with them. Tomorrow we're going to be doing some more complex math with imaginary numbers. So, first of all, an imaginary unit is I. It comes from a negative square root. And we have, in the past, in Algebra 2, you learned that there was an imaginary number. But before that, if you had x squared plus 1 equals 0, and you solved for x, you would subtract 1, right? And then you would take the square root of both sides, and you would say there's no solution. Why would you say there's no solution? Because it's negative square root. Okay, but that's not true. There is a solution. It's not a real solution. So they should always say there's no real solution. There is a solution. The square root of negative 1 is just I. It's called an imaginary unit. The reason why they had to come up with those, and you see most imaginary units when you were talking about electrical work and electricity, and if they just stopped when they got a negative square root, guess what you wouldn't have today? Think about your day this morning. If you didn't have electricity, what would you have this morning? You would have slept in.
Wouldn't have came to school.
What?
Wouldn't have came to school today.
You wouldn't have came to school.
That would have been nice.
Yeah, okay. So you would have been staying home in the dark. But you have no TV, you have no phone.
That's okay.
Yes,
I'd
that's
still
true.
be sleeping.
You'd still be sleeping.
Yeah, I would have slept all day. Would have been
Okay.
really nice.
So the square root of negative 1 is I. The square root of negative 4 is what? What's the square root of 4? 2. So it's 2I. Okay.
Miss Paul's really does come here.
The negative is just that I. Okay.
So,
Once I take care of the I, we're exactly like a problem that we did
I
yesterday.
was gonna say, you just solve and put I behind it.
Because what you have is the square root of negative 1 times the square root of 4. And the square root of negative 1 is what?
I.
Every time.
Nice.
This seems easy.
Okay, so we need to powers of I. Okay, so we need to think about this. I like to think about it in the use of just the math. Okay? You will need to know I to the first, I to the second, I to the third, I to the fourth, and everything after that repeats. You have one problem today that gives you a bunch of different i's to different powers, and you have to figure them out. So I to the first was the square root of negative 1, yes?
Yeah.
But we don't want the square root of negative 1 on our paper, we would just write it as I. So if I have I squared, so I squared would be whatever I is. What's I?
Square root of negative 1. Square.
Square root of negative 1. And then I got to do what with it?
Square. So
Square.
it'd be negative 1.
So it would be negative 1. Because when you square a square root, you get what's inside. Because a square root and squaring are opposite operations. So I have I cubed. So I cubed would be I squared times I, correct? Yes? Okay, what is I squared?
Negative 1.
Negative 1. And what is I?
Square root of negative 1.
Square root of negative 1. So it is negative I. Because we don't want the square root of negative 1, do we? No. So I cubed is negative I.
What happened to that one in front of it's just not.
Yeah, it's there, but not there.
They're just like, oh, negative I.
Okay, so I to the fourth. I to the fourth would be, yep, or we could just do I squared times I squared.
Yeah. Could you do I squared?
Yeah. that would be negative 1 times negative 1, which would be what?
Positive 1.
Positive 1. So you're going to get problems where you FOIL it out and you're going to get I squared and you're going to write not I squared but what? Negative 1.
So anytime we see I squared, I cubed, I to the 4th, it's negative 1?
No, when it's I squared, it's negative 1. I cubed is negative I to the 4th is just what?
What if it's I to
What?
the 5th?
Okay,
Or 6th,
so
or 7th, or 8th.
I to the 5th.
How do you decide what's
It's-
right? What do you do?
Negative 1.
Out of the second I?
I don't really know. Is it negative 1?
I'll have to see. So I to the 5th. So let's break it down in things we know up here. So we're going to break everything else down into stuff up there.
Okay, so
I'm going to do I to the 4th if I can because it's what? 1, right? So I to the 5th would be I to the 4th times I to the 1st, yes, or just I. And I to the 4th is 1, and I is I, so I to the 5th is just I.
Oh, because 1 times I is I.
So I to the 6th.
Why wouldn't it be
I
1
do-
I? Oh,
It would be negative 1.
Okay, so I to the 6th. Which one of these would always be the easiest to use? 1, 2, 3, or 4?
2.
2.
2.
Because it's
4.
4. That's what I said.
Why 4?
Why
Because
4?
it just is 1.
Because it's 1. Yes? So I to the 6th would be I to the 4th times I to the 2nd. So I to the 4th is 1, and I to the 2nd is, so it's negative 1.
I thought we were timing because 4 times 2.
No, we're
Oh,
doing
never mind.
Okay.
You're a silly goose.
Now, so how this works, we're not going to keep going. The pattern keeps repeating.
Yeah.
I to the 7th, can we guess what it's going to be?
Negative 1i.
Negative 1i or negative I.
Yeah.
I to the 8th is going to be what? 1.
Yep.
Okay, but if I give you I to the
Oh god.
27th,
Oh.
Okay. do you want to do all of them before that?
These are
No.
No. So we're going to figure this out.
It's negative.
Maddie kind of gave us a hint when she's like, well, can you do I squared squared? Yeah, you could. Rather than writing I squared times I squared, I could have written I squared squared, correct? Which would be I to the 4th. So what we're going to do is take this 27 and divide it by 4. And why do we like the power of 4?
Because it's 1.
Because it's 1.
Simple.
So 27 is going to be I to the 4th times I to some power. We don't know. So 27 goes into 4 goes into 27. How many times?
9.
6.
6.
Six.
That's what I said.
6 times. And how many were left over?
3.
3. So I to the 4th is what? 1. So I have 1 to the 6th, which is just what?
1.
1. And I cubed was what?
Negative I.
So the answer is negative I.
Joanna, how you did that?
Okay, so we're going to do more.
Explain how you got the 6.
We're going to do more. So I to the Evan, give me a number.
32.
Okay, I to the 32, and I want powers of 4. Why do I want powers of 4?
Because 4 is separate.
Because it's equal to 1. So 4 goes into 32 how many times?
8.
8. Anything left over? Nope. So what's I to the 4th? 1. 1 to the 8th is
1.
1.
1.
Okay, I beat
So give me another number.
Wait.
37.
43.
Wait,
Let me write
this
37.
down. So I can follow.
43.
48.
So
77.
235.
What?
I thought you couldn't times exponent.
When I write it like this, I add. When you multiply exponents, you add. When you take a power to a power, you multiply.
Okay. So then
Because it's outside the parentheses.
I to the
Okay.
100.
100 what?
33.
Okay, so I to the 133rd. So I want to know how many powers of 4 there are in that, because that just reduces down to 1, yes?
Yeah.
And my remainder is actually going to tell me my answer.
Okay.
So I to the 4th. So 133 divided by 4. So 4 goes into 13
Three.
3 with 1 left over.
Yeah.
3. And then how many left over?
1.
1. So this whole thing is just what?
1.
1.
1.
Because I to the 4th is 1 to the 33 power is 1.
Yeah.
Okay? And I to the 1st is I to the 1st. I to the 1st, we're just going to put I to the 1st. We do not want square roots of -1
So
to be written
So
down,
it equals
do we?
I?
So it equals I.
could you put 1? Like it. Like let's say like I'm working on my worksheet. I got like I to 133 equals I. If I accidentally put like I 133 equals 1, like when I get it wrong.
Yes, because that it would be powers of 4. That would be anything divisible by 4 would be 1.
But I thought I equals 1.
No, I equals the square root of -1.
Come on, right? So then could I put? Never mind. Okay, never mind.
Okay, you can put I. That is the only thing you can put. If it is I to the 1st, you can put I, and that's it. Okay. So, one more obnoxious one. I to the what?
327. I don't know.
327, 5, 6. Okay,
Well, there we go, right?
that's obnoxious,
You
right?
know what you want.
Okay, so, okay.
It'll work. It'll
I don't
work.
want that one though. Why don't I
Where
want
you
that?
wrote it and I wrote it in pen.
It's divisible by 4. How do I know that that's divisible by 4?
56.
56. Does 4 go into 56?
Yes.
Yes.
Good.
Why don't you just change the last number to a 3?
8.
Why don't you?
Why are you doing that?
Because
To make it so it's hard.
we did a leftover power of 3, yes. We leftover 3. We did leftover 0. We did leftover 1. So hopefully we have leftover 2. So we're gonna divide this all by 4, yes.
Yes.
Okay, 4 goes into 32.
8.
8. 4 goes into 7
1.
with 3. 4 goes into 35
8.
with
3.
3. Okay, and
9.
9
With I to
with I to the second. So what does this whole thing equal?
1.
1. And what does I to the second equal?
-1. Show your answers -1. Period. Okay, so
Can we just do imaginary numbers for the rest of the year? That'd be great.
on I 27 equals like is that the answer? I 27 equals -I.
Yes.
So one thing Miss Paul taught. Where did you get 27 at?
I just
You're not.
gave you 9 to I to the 27.
Where do you get the -1 at?
Numbers.
Okay, I squared
Oh,
is
yeah.
-1.
Okay.
You have to know these. If I know these, can I find out any other power of I?
Yes.
Yeah.
Yep.
You have to know those.
I know those.
Now.
-1. Negative.
You already knew that I was the square root of -1, yes?
Yep.
Okay. Did I show you how mathematically to figure out the rest?
Yeah.
Yep.
Yes. So if you forget, could you mathematically figure out 1 through 4? Or 2 through 4? You should be able to.
I remember.
I would tell you you're going to use I squared a lot. You're going to use I to the 4th a lot. These come up all the time. Your answers can be I, -1, -I, or 1. Those are the 4 answers that you will have for any of these problems, no matter what the degree. Evan, are you scared of spiders? Can you kill that spider right there?
Oh, hi, bud. What's up?
Where?
Look at her.
Oh no.
Where?
See
It's
it.
over there.
It's just
It's all
do
in the window.
you need a tissue?
Oh, sure.
If you say no,
I like that. Oh, wow.
Dude, look up.
Don't kill it.
Yes,
Kaylee
Kelly.
wants to keep it. Give it to Kaylee. She'll put
how
it
much
in her
left?
Bible bag. I still have not slept in my room.
They belong outside.
They
Okay,
belong to the street.
by combining real and imaginary numbers, we get complex numbers. Okay, complex numbers. Complex numbers in standard form are a plus bi. Okay, a complex number is a plus bi. A is the real part. Bi is the imaginary part. It must be written that way. Real plus or minus imaginary. Your imaginary cannot be in front. That would be like giving me an answer of 2/4 on a test. What should 2/4 be written as? A half.
Half.
A half.
What? You just say
Where do you say where
Two
B
fourths.
is a real
Like
number?
like a square root 4.
The B is a real part of the imaginary.
And either way,
Okay,
Yes, it would. 2 and then you square root of 4.
wait, no, not yet. Not yet.
Yeah, wait, what are we doing? No. Do you? Oh, wait a minute. We're gonna.
Hold on. I think we're jerking.
I'm confused.
okay, so a complex number is a plus bi. A complex number just has an imaginary number in it. Standard form is a plus bi. A is my real part and bi is my imaginary part, where b is a real number, but it has its stuck bi. So, what that is, I have -5 plus the square root of -9. Well, the square root of -9 cannot stay on my paper. So, the negative becomes what? I. And the square root of 9 is 3. So, I'd have -5 plus 3i. Real, imaginary. That is a complex number in standard form.
So that's all it is.
That's all it is.
Awesome.
You know what? I might actually do a
Okay.
full-time one.
I expect every answer in standard form, whether I tell you to do it or not. Just like I expect you to write every polynomial in descending order, whether I ask you or not. That is how you write them. This x, or this I, excuse me, has to be to the side. So if I have -5 minus 3/4, my I has to be to the side. I hate how the pen stays there. It cannot be up with the 3. It's not down with the 4. It's a whole thing. It has to be off to the side.
Where'd you get that?
I made it up.
Okay.
I made this up to show you with a fraction, it has to go out to the side.
So it can't be on top of the 3.
No, it cannot be like, nope.
Okay.
So
Because
that does not exist.
Because what happens here is I put an imaginary number in a real number. Here I have the real number and the
Yeah.
imaginary number.
Separate.
They have to be separated.
Wait. Sorry. So, did you switch around the order or not?
Nope, the order cannot be switched around. That's it.
There's no way.
What? Oh. Oh. No,
Not
Are you good?
Yeah, I guess. I'll see later. But if it was the same thing, there's no way.
Oops. Okay, in reference to a plus bi, real numbers, if b is 0, so if b is 0 right here, I'm just left with a. It's just a real number. It's not an imaginary number, right?
Mm-hmm.
Okay. If it is an imaginary number, b can't be 0, because if b 0, we just learned it was a real number. A pure imaginary number has no real part. It's just bi. And that just says where a is 0 and b isn't. That's just the domain. Or what you need is a pure imaginary number is bi. For every real number, you can write it as an imaginary number. This is just a side note. If I have a, I can always write a plus 0i. just like if I had 6, like if I had x squared minus 4x, can that go in your bag? Plus 6. Could I write that as x squared minus 4x plus 6x to the 0? Yeah, because what is x to the 0?
Oh no. Just
1.
What
Right, x to the 0 is 1. So I can write this like this if I wanted to, but do I do it very often?
you don't need to.
Not,
just,
you don't need to. And I can write any real number with a plus 0 imaginary number if I wanted to. So if I have no real part and an imaginary number, what kind of imaginary number do I have? A pure. I have a pure imaginary number if there's no real part.
So what do you mean like where B can't equal 0? Because
Well, if A is 0 and B is 0, then you just have 0. If this B was a 0, would you have anything?
no.
This is just a domain. Right here is just a domain. To
Okay.
clarify that.
So then on the bottom when you have x squared minus 4x plus 6.
That was an example of how this relates to this. Like I can take any real number and put plus b plus 0i, just the same as I could take any polynomial, and on the constant add x to the 0 or t to the 0.
You're right.
Okay, equality of complex numbers. If I have two complex numbers, a plus bi and c plus bi, if I take a plus bi equals c plus di, I said b twice. Okay, think about this. If I'm saying these two things are equal, okay, don't the real parts have to be equal? Yeah. And don't the imaginary parts have to be equal?
Sure.
Well, I just said they're what?
Equal.
Equal. And for two things to be equal, they have to be equal. So
Right.
this is one of those, in every part of algebra we get to, we have duh theorems. And they're usually the equality ones because this is a duh theorem. If I say the left equals the right, then the left has to equal the right? So what it says is this happens only if the real part's equal and the imaginary part's equal. And if you think about that, that would have to be true. So an example of that is if I have a plus bi equals 13 plus 4. What's a? 13. Why, CJ? Because this has to equal this if the whole thing's equal, correct?
Yes.
What's b? 4. For the same reason. Okay, so that was basic, right? So now we have a plus 6 plus 3bi equals 6 minus 5i. Well, the real has to equal the real, and the imaginary has to equal the imaginary, correct?
Yeah.
0.
So a plus 6 has to equal what? 6. And 2b has to equal
-5.
-5. You notice I didn't put the i's there. That doesn't matter. There's an I on both sides already.
Oh, okay.
Okay? So then I just have an algebra problem, correct?
Yeah.
So a is 0
Yes.
and b is
-5/2.
-5/2.
And that's what it is.
And if I plug them back in, I'd have 0 plus 6 plus 2 times -5/2 I, correct?
Yeah.
0 plus 6 is 0. 2 is reduced, and I get -5i. Is that what it should have been?
Yep. It's
Yes.
unequal. So
Okay.
that is all it is.
Yep.
That's all.
Real equals real, and imaginary equals imaginary. Can I give you equations in those to have to solve? Yes, but real equals a real, and imaginary equals imaginary. Do not, again, don't worry about the eyes because the eyes are already there.
Okay.
Wait, you just ignore
If the
that.
eyes aren't there, be scared.
What? I'm.
So if you're ignoring the eyes, what happens? So instead of adding the 6 and the 2bi, you just separated those and made 2bi equal to 6. It's not really different.
Why would I add them?
Because there's a plus in between them.
Well, but this is real and this is imaginary, so they're not like terms. So I can't add them anyway. I'm just solving for the variable. And yes, eyes take the same rules as variables with like terms. Same rules as radicals. If they're not alike, you can't do anything with them. Okay, addition and subtraction of complex numbers. This is what's in the book. I don't really like what's in the book. I personally would not write this down. But I want to read it to you so you can understand what it says. And we'll figure out something else to write down. Because reading this in the book, which is important to figure out, but is not what you should write in my notes. Why?
Because not the way you do it.
Yeah,
It's confusing, right? So my notes need to be something that makes sense to me, right?
Yeah.
So it says addition and subtraction of complex numbers. If I have a plus bi and c plus di are two complex numbers written in standard form, their sum and difference are defined as follows. So if I have a plus bi plus c plus di, what did they do over here?
They.
Combined
Added
by
both
terms.
real numbers and added both imaginary.
They added the real numbers and added the imaginary numbers. Okay, so the difference, right here,
Subtract both real numbers.
subtracted the real numbers and subtracted the imaginary. So, in my words, I would write addition and subtraction, or add and subtract two complex numbers. You add or subtract the real and the imaginary parts of the number separately. Or you can write their definition if you like that.
I like that.
I like where you just add the real, you add the imaginary, and you're done.
Wait, what was your definition?
My definition is right here.
Oh.
You add or subtract the real and the imaginary parts of the number separately. Real go with real, and imaginary go with imaginary. Combine your like terms, guys. That's all it is. And I would honestly say distribute your negative right here and combine like terms. Because imaginaries are like terms, right? Reals are like terms. Those are all words you're used to. If I gave you two polynomials to subtract, you'd distribute your negative and combine like terms, right? Same thing here. It's just a polynomial. Same operations all apply. I will always give you the book definition because it's important to be able to learn to read those and understand them. But if you're ever reading the book, they usually have like the technical math definition in the box, and then right under it, they give you like a layman's term kind of definition of it.
So basically, you flip the sign. No.
We'll do it. We'll do an example. You just distribute, and you're just combining like terms. That's all you're doing.
That's the same equation as the top one. Like you didn't combine anything.
Right. Oh, they took this negative, and they made it negative here and negative here. If I were to do this problem right here, I would have a plus bi minus c minus di, and I would combine a and c and b and d because they're like terms.
So you're always gonna want that, like for the sum and difference. Well, you're always gonna have a minus c plus b minus d.
Well, if that's subtraction, we'll do it. We'll do an example. Did we not have an example?
I said example.
But I don't think it's of that. No.
I swear it's example.
Okay, so 7 minus 3i plus 6 plus 7i. Okay, this addition does not do anything, like I don't have to distribute, it's just addition, right?
Yeah.
So I basically have 7 minus 3i plus 6 plus 7i, yes?
Yeah.
Okay, so what are your real parts? 7 and
7 and 6.
6, so you get what?
13.
13. And I get negative 3i and positive 7i, so I get
4.
4i. All I'm doing is combining like terms. That's all I did, isn't it?
Oh.
That's why I kept telling you. All it is combination of like terms.
Oh.
Okay, so I have 6 minus 4i minus 5i minus 4i. So what do I need to do before I do anything here?
Distribute the negative.
Distribute the negative. So I have 6 minus 4i minus 5i plus 4i. And what's, oh,
Why would
I have 2 i's. I
You
should not
gotta
have
get
2 i's. I don't know why I put 2 i's in there.
Why would it be plus though?
Because she distributed the negative.
So do you
the
just
negative,
distribute the negative on
positive.
the last
Oh,
one?
okay.
Yeah, that's just like any other polynomial. And then what do I get?
6 and negative 5.
6 and negative 5, so my answer is just
1.
1.
So, when you're gonna be
Distributing.
taking that negative out and then adding it. So, like, what you did was take the subtract sign between the two parentheses and then take one of the subtract signs in one of the parentheses and made it a plus sign.
Well, yeah, because this is positive 5 times a negative 1 is negative 5. This is a negative 4 times a negative 1, which is positive 4.
Oh,
Okay, so that's addition and subtraction.
Okay.
All you do is combine like terms, correct?
Yep.
Okay, that's it.
Always multiplying.
We're not going to overthink this at all. Now, additive identity in a complex number. Don't write all this down because it's not, I want you to think about it. What is the additive identity of any number? Identity means I can do it and never change it. So what is the only number I can add to anything and not change it? 0. So guess what it is in complex numbers? 0. That's it. Says the additive identity of complex numbers is 0. Okay, that's it.
Okay.
Okay, now we have an additive inverse. Inverse means the opposite. Can't talk. So if I have a plus bi, the additive inverse, meaning moving it to one side to the next, right? I would add a negative or subtract a positive, correct?
Mm-hmm.
So I would distribute a negative through it and get negative a minus bi. So when I put this and this together, what should I get? 0.
So you're just trying to make the first term 0.
Yes, what it's saying is we can solve equations using math with these, basically. So if I have this, we got to evaluate it now. So a minus a is what?
0.
0. And b minus b is,
0.
so the whole thing is
0.
0. All that is saying, guys, is if I give you equations, can you move things from the left to the right by addition, subtraction? Yes. Every math you can do with an x, you can do with an I. The only thing, x is a variable, is I a variable?
No.
No. What is I?
Imaginary.
But what is it? What's it?
Square root of negative 1.
Square root of negative 1. Okay? Just like any, have you guys ever been introduced to E? You will be soon.
Introduced to what?
E.
No.
Okay.
Oh.
E is not a variable, it's a value. 2.718281828182818281828. Similar to pi, except it repeats because I kept going 18281828, right? Is pi a variable?
Yeah.
Is pi a variable?
It's a
No.
value.
It's a value. It is a symbol for a number that's non-repeating, non-ending, yes? So is I a variable? No, it's a symbol for what?
Square root of negative 1.
Square root of negative 1. Okay, so I think we can do these. You guys want to do these real quick on your own since we already did them? Are you ready for me to start working on? Like, you're good?
Yep, I got it.
Hey,
What'd you guys do? Any thumbs?
I haven't started.
The first one you haven't started?
No.
Oh, okay. Don't look at the answer then. Caleb, did you have a question?
Yeah, but no.
Well, ask it.
No, because it's not like, it's not.
Here, I'll come back. Go on to B if you got A done.
It's, I can just ask it tomorrow. We have to write 0i.
If it says write your answer as as a complex number in standard form, yes. If it does not, then the answer is just what?
Negative.
-3.
What if we write 0i on one that you don't have to? Is it wrong?
No. It's wrong if you don't put it and it says write your answer as a
So pretty
complex.
much just put 0 on it to be safe.
Every number from here on out.
Yep. Every number needs
So,
a plus 0.
so how did these go? Good?
I had a good time with them.
Okay. Remember you have to do what with this negative?
Distribute it.
Distribute it so it's -4 and -2, right? I was just making this negatives really big to go in there. So you distribute the negative and combine like terms, just like you would any polynomial that I gave you, right? Like we did last chapter when we subtracted polynomials. You're doing the same thing.
I just took 1 minus 4 and 2 minus 2.
That's what I did.
Oh, well, you said
Yep, 1 minus.
Well, but you still have to you're distributing the negative. You just did it differently.
Oh.
Okay, what am I going to do here?
You.
5.
What do I have to do with this negative?
You just distribute the negative.
So I have 2i minus 3, right? What do I do with this?
-2.
And then, so then I have -2 minus 5i. And then what do I do with all these?
Combine them.
Combine them.
Ooh, there's the,
So,
I forgot about the
2 -2 is out,
-5i.
just -5i.
Nice.
And what kind of an imaginary number is that?
A good one.
A pure one. Why is it a pure one?
Because it's not a real number.
There's no real part. So try the next one. Oh, the next one's even easier.
Oh, wait. I'm not done yet. Okay, then you just distribute.
Wait. Okay. Wait.
You, why is it?
Oh, never mind. Got it. I got it.
That's good.
I was like confused for a minute.
You good, Riley? You got it?
I'm so proud.
It wouldn't be too
Oh, that's
high.
not right.
No.
What did I forget to do?
Um,
My answer was
Distribute.
2i.
that's it.
The answer is 0.
Yeah, the answer is 0. My first answer was 2i.
You forgot
What-
to distribute your negative
To the what, specifically?
to the.
To the i. I distributed it to the 7, but I forgot to distribute to the i.
Yeah.
0.
Yep.
I said 0.
It's just 0.
Do you have one of those worksheets?
Yes.
Yeah.
Okay, so you guys got all your stuff to do.